On to standard 5. Now what we're dealing with in part of standard 5 is right triangles. Now a right triangle, and by the way there's 3 ratios you need to get familiar with. It's sine, cosine, and tangent. Now if you had Algebra 1 last year we did a little bit of this, and if you'd taken geometry you did it at the end of the year. And those can be located on your calculator: sine, cosine, tangent. Okay. Now, so that's a right triangle. It's called a right triangle because it has a 90-degree angle, as most of you know. Okay, that's 90 right there. Okay, now, there are 3 sides of a triangle. Okay, they're called the hypotenuse, which most of you are familiar with, but there's 2 other sides. They're called the legs in geometry, but in algebra we call them the adjacent side and the opposite side. Now, we know the hypotenuse. Put your pencil on the right angle and just go straight across, and that's the hypotenuse. Okay. Now, the other 2 sides, the adjacent and opposite, it depends where this symbol here is at. It's called theta. That's spelled wrong. It's T-H-E-T-A. It's just like a Greek symbol. Now, you put your pencil on theta, go to the other side, and you need to take this part seriously because without knowing how to label these, you're never going to know what you're doing here. Opposite from that, when I go opposite from that, that's always called the opposite side, the O. And then the third side then is obviously my A. I always go H, find the theta sign, O, and then A. So let's practice that on this one. So that's the H. There's the theta sign, so that side is known as the opposite, O, and this is the adjacent. Now, sine, cosine, tangent are ratios formed by those sides. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So I want you to tear this paper off, and you're going to keep this paper for reference. So I'll write sine, cosine, and tangent. And then here's what I want you to do. Sine is O over H, opposite over hypotenuse. Cosine is A over H, the adjacent over the hypotenuse, and tangent is O over A. Now there's a way to memorize that works pretty slick. So, ka, toa. Okay? Sohcahtoa. It's like a Native American's name, Chief Sohcahtoa. 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 Okay, so let's go to this problem here, and our job is to find the 3 trig ratios of the angle. Now they're called sine, cosine, tangent. So when they're asking for the 3 trig ratios, you put sine, parentheses theta. Cosine, you can put cos, parentheses theta. Tangent is tan, parentheses theta. And we got to find the 3 ratios that these are equal to. Okay. Well, I got to know what's what. Okay. Now remember, sine is the O over the H. The cosine is the A over the H. And the tangent is the O over the A. Okay. So just like you see here. So I have 2 of my sides, but what are they? So across from there is my hypotenuse. So I don't have the hypotenuse. Okay. Put your pencil on the theta sign. That's O. O is 3. And then the third side is my adjacent. Okay. So I know the opposite is 3, the adjacent's 4, but what about the H? Because I'm obviously going to need H. Okay. Well, that's the Pythagorean Theorem, but instead of a squared plus b squared equals c squared, we write a squared plus o squared equals h squared. So a is going to be 4, so 4 squared. O is 3, so 3 squared. And h is unknown, so I call that, I'll just leave that as h squared. Now, figure out the second powers. That's 16 plus 9 equals h to the second. And then since these are on the same side, we can add those. 25 equals h to the second. Then we have to find the square root of 25. Because some number times itself is 25. What is it? Okay. And that's 5. So 5 is equal to h. So I go put 5 next to my h, and now I can fill this out. So O is 3. So h is 5, so 3/5 is the sine. Cosine, A is 4, h is 5, 4/5. And tangent, O is 3, and A is 4. Okay, and that's complete now. That's what you're doing on this assignment. Now on the next one, same idea. We got sine of theta, cos of theta, cosine, tangent of theta, and I got to find these ratios. So again, sine is O over h, the cosine is A over h, and our tangent is O over a. Okay. So again, I have two sides. That's all on this assignment. We always have two sides. So opposite that's my hypotenuse. So I know the hypotenuse to now is 17. Okay. Across from that's your opposite, and then the a, and that's 15. A I don't know. Okay, so I have to use the Pythagorean Theorem then to find my other side. So a to the second plus o to the second equals h to the second. That's our new Pythagorean Theorem. So a I don't know, so I leave that letter in the equation. O is 15, 15 to the second power. H is 17, 17 to the second. A to the second. By the way, 15 to the second is not 30. Okay? 15 times 15 is 225. Okay, and then 17 to the second, it's not 34, it's 289. Okay, so this time I can't just add them, so I need to subtract 225 from both sides, and that's 64. So a to the second power is 64, and then I need to find the square root of 64. Well, that's easy, that's 8. So put 8, and now you can fill it out. So O is 15. H is 17, A is 8, H is 17, O is 15, A is 8. Okay, moving right along. Here's my theta, so I need to find the sine of theta, the cosine of theta, and the tangent of theta. Okay, so sine is O over h. The cosine is A over h. And the tangent is opposite over adjacent. Okay? So what side's what? So across from the right angle, that's my hypotenuse. That's 14. Now go find the theta sine, and that's O. I don't have a number for O. And then A would be 9. So A to the second power plus O to the second power equals H to the second power. So A is 9, 9 to the second. O we don't know, so O to the second. Remember, that's not 0, that's a variable O. And H is 14 to the second. Okay, 9 to the second is 81. O to the second. Then I take 14 to the second, and that's going to be 196. So subtract 81, because you can't add them. And O to the second is 105. Then I'm going to find the square root of 105. And I'm personally fine with you doing decimals here, okay? So 10.25, round to the nearest hundredth. A 6 makes a 24 into a 25. Please round correctly, though. Now, if I wanted to be a real jerk, okay, I could make you divide these by all the perfect squares that are up there on the board, but they don't divide by anything. So some teachers would just make you leave it as a square root of 105, okay? And just you put square root of 105. I'm not going to do that, okay? Okay, so O is 10.25 and H is 14. A is 9, H is 14. O is 10.25 and A is 9, okay? Now again, if I want to be a real jerk, I would make you divide this by all the perfect squares, and if you can divide, it's divisible by something, and without a decimal, you could, you know, break it up into 2 square roots, okay, but that's not here, okay. And so instead of these 10.25s, you would just put the square root of 105. You might have to do that in trig. I don't know what Mr. Larson's going to want you to do, okay. Now, it's really crappy, but I can work with it. It's a crappy drawing. I'm not a good shape drawer. Okay, it's a good thing I'm not the geometry teacher because I cannot draw a regular equilateral hexagon, okay, or an octagon, but we're dealing with triangles. Okay, so the sine is O over H, the cosine is A over H, and the tangent's O over A. You should be getting the hang of that now. So O to the second plus, sorry, keep it consistent. I guess the O and the A, the order doesn't matter, but just keep it consistent. So here's my right angle. So that's my hypotenuse. That's your opposite, 7. That's your adjacent. So the adjacent's the one we don't know. Okay, so O is 7 to the second, and H, 15 to the second. Okay, so 7 to the second is 49. And then 15 to the second is 15 times 15. It's not 30, 225. You write 30 down, you're pretty much DOA, because if you subtract 49 from 30, yeah. Okay, so I take 225 divided by 49. That's 225 minus 49, excuse me. That's 176. And then we find the square root, okay? So we'll square root that on the calculator. 13.27, because the 6 would round it to a 7. Now again, don't write 13.27 down. Don't write this next thing down. In some other classes, they would make you divide by all the perfect squares on the board. And 176 is divisible by 16. So then you would make 2 square roots, put the 16 and the 11. And instead of writing 13.27, you would write 4 square root 11. Okay? And that would be your A. I'm not going to do that though. Okay, so your O is 7, your H is 15. Your A is 13.27, and the H is 15. And then your O is 7, and your A is 13.27. Okay. Now again, if you had some other teacher, he might make you do, instead of just square rooting it, writing in the decimal, 4 square root 11 would go here and here. And then, like, I don't know if you did it in geometry, but the square root of 11, you know, you'd have to multiply. Yeah. Okay. So we're just good with decimals. Okay, that's all I have to say on that. I hope it has been informative, and you have 2 problems to do, finding the trig ratios. You don't have to reduce your fractions. You can if you want.